Good afternoon, students. I am going to present my lecture on the fundamentals of communication engineering, that is KEC 101T. It was all about the communication fundamentals. So I am going to teach you about about the signals. What signals we are going to use in communication. So we are going to cover up the basics of signal representation and analysis, and after that I am going to cover the electromagnetic spectrum. Now, first of all, we have to learn about what is signal. Signal is a method or means or the combination of all the information of any kind of uh, person or place to another for the direct communication. So, the example of if we see the example of signals, we have a different type of signals in day-to-day life. We have a sound signal, spread alarms, attract for the attraction of attention, and we can transmit a short type of signals also. So there are some limitations of signals. We have the sound signals which are not secret, and they are maybe used many prohibited for the security reasons. So if we have going to look about the different type of signals, we have basically two types of signals in this. We have analog signal and digital signal. Basically, analog signal refers to something which is continuous in nature, and it is a set of data which is obtained at different possible points. This shows the example of analog signal, which we can see here. It is the continuous in nature with respect to time. The next type of signal is digital, which refers to basically something which is discrete in nature, and it is a set of specific points with no other points in between them. So we can see here the example of digital signal. It is in the form of discrete values, that is in the form of zeros, ones, zeros, ones. So here we can say how the digital signal can be obtained from a continuous signal. So this is called basically the sampling process, in which we can see here we can take the different set of points for the discrete signal. Now if we talk about only the analog signal is a quantity, that means it defined with respect to time, and it is continuous in nature basically, and it is the signals which can be defined over continuous independent variables. They are difficult to analyze, and it has huge in number values, and they are very much accurate due to the large sample of values. So in order to store these signals, you require infinite memory, because it can achieve infinite values on the real line. For example, we have the sine wave. This is the continuous signal, and it is analog in nature, and it is continuous with respect to time, and it has a different set of amplitudes at different instant of time we can obtain here. So now if we compare it with the digital signals, it is the digital signal is very easy to analyze because it is discrete in nature. It is in the form of ones and zeros. So they are appropriate for analog signals. So the word digital stands for discrete values. Hence, it can be used to represent any information in the form of ones and zeros, that is the binary values. Now if we take a digital signals advantages, then it is less accurate. Disadvantages than analog signals, and because they are discrete samples of analog signals taken over the some period of time, so digital signals are not subject to noise. These comes under the advantages of digital signal. So they can last long and are easy to interrupt. Digital signals are denoted by the square wave, that means it is in the form of 1 and 0 pulses. So this, if it is high, it is called 1, it is 0, then it is 1, then it is 0, and again 0. Now next come to classification of signal. This you have to understand, and it can be classified in different forms. But first is continuous time signal and discrete time signal. Second is deterministic and non-deterministic signal, even and odd signals, periodic and aperiodic signal, energy and power signal, real and imaginary signals. So let us talk about first continuous time and discrete time signal. As the name says, continuous time signal is continuous in nature with respect to time, and we get the signal at every instant of time. And if we talk about the discrete time signal, it is discrete at an instant of time, and this is the example of discrete signal. we have a different amplitude of signal at different instant of times. Now next classification is deterministic and non-deterministic signal. In this, if we talk about first deterministic signal, as the name says, deterministic is which can be determined easily at any instant of time. So the signal is said to be deterministic if there is no uncertainty with respect to any instant of time. So this signal is deterministic because this can be determined at any instant of time and its amplitude can be determined easily. But if we talk about the non-deterministic signal, that it is uncertain and its value cannot be predictable at any instant of time. So non-deterministic signals are basically random in nature, and these random signals are basically not represented by any mathematical equation easily. So they can be represented like this. This is random in nature. We have a different amplitude of signals at different instant of time, which does not have any periodicity and any symmetrical nature. Now next comes to even and odd signal. The signal is said to be even when it satisfies this condition, that is xt equals to x of minus t. Basically, this is the condition which we observe in, if we let us take the example of sine wave. If I am taking the example of cosine wave cos of theta. So if I am taking theta equals to minus theta, then cos of minus theta is equals to, it is coming out to be cos of theta. So this can be taken as the example of even signal in which negative sign is absorbed. So if we draw the cosine signal, this cosine signal can be drawn like this. This is the original form of cosine signal with plus theta, and if we had reversed the minus theta, if we had taken the negative part of the angle, this is the minus theta, and if again I am plotting this, I am getting this positive signal, but only the signal is going to be symmetrical about the y-axis. So this is the case of even signal. In this case, I am getting the even signal. Now if we talk about the odd signal, a signal is said to be odd signal. It should satisfy the condition xt equals to minus of xt. So in this, we can take the example of sine wave, sine of theta. If I am taking again same example as, if I am taking sine of minus theta, I got minus sine theta. And if I draw it graphically, I can obtain like this. This is the input signal, sine theta. Sine theta is drawn like this. And if I am going to plot this sine of minus theta, I got the signal like this in the negative theta axis, and it can be drawn like this. So I can say here I am getting the anti-symmetry along the x-axis. I am getting the anti-symmetry along the x-axis. So this is said to be odd signal. So this is how we can satisfy, with the help of example, the two conditions, that is the even signal and odd signal. So this can be the relations ft. If we take the combination of even and odd signal, it can be expressed as, ft can be expressed as the sum of even signal plus odd signal, where the fet is equals to half of ft plus f of minus t. So this is the relation which can combine the even signal and odd signal terms. Now next come to next classification, that is the periodic and aperiodic signal. Basically, what is periodic? Periodic signal is basically the signals which repeats over a particular period of time. So a signal is said to be periodic if it satisfies the conditions. This is the conditions which we can satisfy in periodic signal, and this t represents the time period over which the signal is repeating. So these are the two conditions. One is for the analog signal and one is for the discrete signal. This is satisfying the analog conditions and this is satisfying the discrete conditions. So if I am taking the example of analog condition, sin t is the example of analog conditions for the periodic signal, and if we plot this, I am drawing this signal as like this, and it is repeating after every 2 pi interval of time. So this is satisfying the periodic signal property, that is x of t plus capital T equals to x of t. So t is, I am taking here the time period as 2 pi. So this is said to be the periodic signal. Now if we take about the discrete signal, same discrete signal is also like this. It is repeating after the n interval of time. We have a n interval of time. So if this is the pattern I am here, I have having with. So this pattern is repeating after the n interval of time. So this is the example of discrete signal periodic classification. So now next, aperiodic signal are those signals which does not repeat after the time period t. So the signal which is not repeating after the time period t, let us take the example of that. That is the non-periodic signal which is not repeating after the time period t. That means x of t is not equals to x of t plus capital T. So example for this I am taking as exponential signal, exponential minus of at. This signal, if I am taking, this is the example of non-periodic signal. So if I am drawing this signal, this is the signal which is drawn like this, and this is not repeating after the time period t. So that's why it is called as aperiodic signal. Now next classification is energy and power signal. Energy signal is said to be the signal which has finite energy and infinite power. So this can be expressed by the relation energy E is equals to minus infinity to infinity x square t dt. This is the energy relationship of any signal, and if a signal is said to be power signal, then it should have the finite power and infinite energy. So power signal can be defined by this relation, that is limit time period is tending to infinity 1 by 2t integral minus time period t to capital T x square t dt. So in this we can say both the signals are defined for different type of energy. So energy signal is defined for finite energy and power signal is defined for finite power. And in these two cases, for energy signal we have power equals to 0, and for the power signal energy is equals to infinite. Now next classification is next topic I am going to cover is electromagnetic spectrum. So all of you know about electromagnetic spectrum is a range of frequencies or range of wavelengths that can be thought as a different particles which is moving with the speed of light. So on the basis of that we have a different bundles of energy, or we can say photons is traveling in the form of a whole electromagnetic spectrum. So electromagnetic waves can be thought of as a stream of particle where each particle is moving with the speed of light, and each particle contains a bundle of energy, and this bundle of energy is called photon of light. So in this electromagnetic spectrum we have only able to see the visible spectrum. So basically visible spectrum includes 7 different colors of light, that is waveguide. So if we talk about a whole electromagnetic spectrum, we have a range of spectrum which is varying from X-rays up to the gamma rays. X-rays, gamma rays, ultraviolet rays, visible range of light, and this can be seen through this spectrum. So this is showing the electromagnetic spectrum, and in which we have energy of photons which is shown below here. So we have both the ranges in wavelength form or in the frequency, and having different frequencies and having different wavelengths ranging from radio waves to gamma rays. We have a very high wavelength of radio wavelengths and a very low wavelength for the gamma rays. That means for higher wavelength we are corresponding to lower frequency and moving from lower frequency towards the higher frequency side. So in between these, we have the radio frequency range, we have microwave frequency range, we have infrared, we have visible range, and we have ultraviolet, we have X-rays. These different wavelengths and different frequency wavelength regions have different applications in different areas, like in communication system, in biomedical application, and in different television communication, any devices. If we talk about the microwave ovens, in that all we are looking for different type of frequencies and different type of wavelengths. So if we talk about the applications and range of frequencies, we have a different range of frequencies corresponding to different applications. So if we first talk about 30 to 300 hertz, this is the range of wavelength 10 to the power 7 to 10 to the power 6 meter. This comes under extremely low frequency. So this has an application in power line communication. Now next range is 0.3 to 3 kilohertz, and it is ranging from 10 to the power 6 to 10 to the power 5 meter. Basically this comes under voice frequency, and in this we found applications in face-to-face speech communication and simple intercoms. The next range is 3 to 30 kilohertz, and it is ranging from 10 to the power 5 to 10 to the power 4 meter. This comes under very low frequency range, and this found many applications in submarine communications. So this have a very great application. So every frequency range has different application. Now if comes to 30 to 300 kilohertz, 10 to the power 4 to 10 to the power 3 meter wavelengths, this comes under low frequency range, and it again have found applications in marine communications. Now come to the medium frequency range, which is ranging from 0.3 to 3 megahertz, and it has a great applications in AM broadcasting. From the foundation of this frequency range, basically the communication is going to start. So that is, in this frequency range we have basic communication started due to the advancement of AM broadcasting. Now if we talk about the high frequency range and very high frequency range, these two frequency ranges are in megahertz range from 3 megahertz to 300 megahertz. And this found many applications in landline telephony and FM broadcasting and television. And this leads to the foundations of many starting of the many communication activities which is used in day-to-day lives with the help of landline telephony, FM broadcasting and television. Now next comes under the ultra high frequency and super high frequency ranges, that is ranging from 0.3 gigahertz to 30 gigahertz. So basically these frequency ranges, again it can be used in televisions, cellular telephony. So this has great applications and advantages in our today's scenario. And also these high frequency range of 30 gigahertz, which we call as super high frequency, it can be used in microwave ovens and found in radar applications. So these different frequencies have many important applications. Now next come to extremely high frequency, that is basically used for satellite communication. And as the satellite communication started, we all know we have a great source of communication and it covers all the worldwide. So satellite communication and radar communication started with the foundation of these frequency range. And we have another frequency range, that is 0.3 to 3 terahertz, that is used for experimental purpose, and that is reserved for experimental purpose, and this can be used for all type of new exploration. These frequencies can be utilized. Now if we talk about the terahertz frequency range, that is 43 to 430 terahertz and 430 to 730 terahertz. These two frequency ranges, that is the infrared and visible light, these two are basically used in LEDs, laser, television remotes and optical communication, which is the great source of communication which is using in today's scenario. So all the high bandwidth applications we can do with this frequency range. Now next comes to the 750 to 3000 terahertz, that is the ultraviolet range of frequency. This frequencies we found its many application in medical field. So in medical field we found this frequency range because of its high frequency. It can be used for high penetration, depth imaging in medical fields. And if we go more higher than 3000 terahertz frequency range, that is the X-rays, gamma rays, cosmic rays, it again found so many applications in medical fields, which we all know about, that is for brain tumor application, for any diagnosis purpose, any detection purpose, any disease detection in our body can be easily done with the help of these rays. Now next, so if I am summarizing all these topics, we have studied about all the basics of signals, which is very important for the communication engineering. So if we want to study about the communication system, first we know about what are the signals and which are the different type of signals we are using in different day-to-day life, and how it can be categorized. So basically we have two types of signals, analog and digital signals. So now if we talk about their advantages and disadvantages, analog signals have number of advantages, that it gives you the better accuracy as compared to digital system. But for digital transmission we found that it is very fast and noiseless. So nowadays it is preferred to have a digital communication system. Next we have studied about the electromagnetic spectrum. Electromagnetic spectrum covers all the frequency ranges from 30 Hz to 3000 terahertz, and we had seen all the different applications for different frequency ranges. So this is all about this lecture. So we will going to cover up all different next topics in for the communication engineering in next lectures.